All right. It's my pleasure today to introduce the session number 2, which you could probably see is called Around Frei Otto. So what you can hear now, we're a little bit zooming out from the Frei Otto's personality to a larger network, and we would like to hear the inputs from the colleagues from, as Professor Bletzinger calls it, from outer space. And that's a really great honor to introduce today Professor Kai-Uwe Bletzinger, who will give a keynote. Professor Bletzinger is a Professor Emeritus at the Technical University of Munich, former head of the chair of structural analysis, and renowned expert in the development of the form optimization and form finding methods. In the late 1970s, early 1980s, Professor Bletzinger studied here in Stuttgart civil engineering at the Institute for Structural Mechanics under the supervision of Professor Eckehard Ramm, and he himself been a research associate at the Sonderforschungsbereich, so Collaborative Research Center 230 on natural structures, lightweight construction in architecture in nature, initiated by Frei Otto, and in this context you earned a doctorate on the form optimization of surface structures. So the stage is yours, please.
Okay, so thank you very much for the kind introduction. And it's really the case. You never think that you will be emeritus until it really happens. So it comes all in a sudden. But I enjoy it, definitely. So it's a great experience. Yeah, so the talk is about impressions from and interactions with outer space. And that's motivated by the fact that I think I am a member of outer space, in that sense that I was really a good guest here. At the beginning of Sonderforschungsbereich 230, I think I was here every week at least once. So it was a very intensive time. Yours, you agree? Yeah. So and I still have very good remembers, and the impact, the inspiration of everything what happened here within the tent, was really driving my later scientific career until today, and it will be my last lecture. Yeah, so if we talk, I know that it will not work when we have the laser pointer. So when we talk about Frei Otto and the spirit of lightweight construction, we realize that Frei Otto and the spirit have been always the center of gravity in a large respect. And what you see here are two orbits of people just around him, just giving the impression about the strength of this gravity field. And we see here the orbits. And the first thing what I would like to introduce is a measure. So we have 1 foot, which means Frei Otto orbit diameter. Yeah? And you see already the second foot. Yeah? And throughout this lecture, I would like to invite you to think about what is your foot? Where are you? In which orbit are you cruising? Yeah? That's quite interesting, and you will realize that you will cruise in several orbits. One's closer, one will outer, and so. Yeah, and having now this observation, we see it all the time. Yeah, we see it all the time. Yeah, these orbits around Frei. Yeah, here. Where's Frei? And here. Yeah, here and there. And watch it, even today. Yeah, and coming back to myself, that's me here. And I think I never came really closer than 5 foot, something like that. Yeah, that's you. I know that you came closer. That's Werner, and he definitely came closer. Where is he? Anyway, yeah. So these are the thoughts. And when I was just developing this lecture, I realized that I had been within the gravity field very early already in my life, and certainly it was surprisingly 1968. And my father, who also was an architect, had the project here in Warmbronn, and it's just 1 kilometer, which perhaps might be really 1,000 foot, something like that. Yeah, but if we go more generally, and we realize that the strength of Frei Otto and his charisma is so large that we can really go in outer space, the largest diameters you can think, and we still feel the gravity at the center where everything just takes place. Coming directly to 230, SSP 230, which was my experience here with him and the tent and everything what is here. And we have already heard a lot about it, so I don't have to repeat it. Yeah, the relation between nature and structures and how they are related. And I came into that and stepped into that as a co-worker of Gerhard Ramm. I just started as a PhD student in 1984. And later I had the honor also to be co-partner here leading this subject. And if we just look into Frei Otto's thoughts about the SFP 230, that's how it looked like. And we may think also again about an orbit here, with many strange or complex, let's say, interactions, like looking into the brain of somebody. Perhaps that's an insight into the synopsis of what the SFP 230 was like. We have heard quite a lot of the philosophy of Frei Otto today, but nobody, I think, was talking about the umgekehrte Weg and the opposite route, which was one of the very driving forces of what we did in our project, with what's called structural optimization of natural and engineering structures, whatever that is. And that was reflecting Frei Otto's idea of what it is, the opposite route. It means rather than taking copies of nature and just building these little tiny things in a larger scale, the idea was to find the principle, the form-finding principles, and why these structures became the shape of the form, as we just observed it, and apply this principle in a technical approach to other scales, to other kind of applications, and by that finding ideas and let's say proofs why we observe what we observe. So it was the first interpretation of myself when I started in 85, something like that. We're looking at reality. We adapt the natural rules. We make a model out of that, and applying this model just to receive insights, and be able to judge about what we see, and also able to take prophecies about what will happen, perhaps at least in close future. That was the approach. And then I, respectively we in the group, started to take our work and develop computational rules and approaches to do optimization. We talk about objective functions, constraints, what are the variables, what are the load cases. And I was very proud when I, after some time in 85, came up with the first result. And that's what I showed. That's a copy of the slide I have prepared. And with the example of a 5-bar little truss, with that as an output. That was a problem, because Frei Otto stood up and said, "That is not correct what you're doing here." Big upset. What did I wrong? The only what I want to do is say, hey, we have prepared the method, and we can now start to apply it. We can talk about objective functions. And Gerhard, remember, we have been invited to stay behind after class. We have been sitting here, I remember, and Frei Otto, he was standing up there and shouting to us, no, but at least talking to us down there. And he was explaining to us what should be the correct shape of a structure like that. And that was one of the days I really had 0 thoughts. So it was completely close and in a different context as expected, but that was the closest ever, definitely. So, that was, of course, a misunderstanding. What I did was something else, as Frei Otto was talking about. And if I would have read about everything, what he did in this regard, and what some 10 years later was written down in year 24, I would have known what is the different approaches. And when we talk about that, we have heard it in one of the previous talks, we easily come to Big and Tra as the basis of the whole thing. And in particular, I would now talk a little bit about the Tra, with this formula, whatever it means just now, but please also the architects keep this formula now in mind. You will see it again, and that's all what I expect from you, just observing, that is the same formula. So the sum of the forces times the transition distance of the force to the support, that's what it means. So, and then we come to the certain application, which are these Mitchell structures, and exactly that was the world Frei Otto was thinking in, Mitchell structures that I was not prepared for. So, and for the expert among you, the equilibrium of every structure is just determined or expressed by the virtual work or the virtual energy, which is supposed to be zero, don't matter what it is. And for the experts, if we just apply this displacement as the virtual displacement, we end up with this formula. Architects do recognize what we have. What is it? The TRA. So Frei Otto was talking about the virtual work and the virtual energy. At least he did it, perhaps not knowing about it. And it was quite also an insight for me when I just was working here on that it was indeed the TRA, a discussion and a variation of what is it, the external work. The sum of the forces, applied forces, also the support forces of the structure, and the transition distance between the point of application towards the support, something like that. Yeah, and there entered the impact of Frei Otto, because he was always creative and came up with certain other ideas, and the interpretation of this formula, that's exactly what is his impact in that. First of all, we can divide that into TRA of the external forces, the load applied, and the TRA of the reactive forces. Yeah? And also, as it is equivalent, the external virtual work to the internal one, we can also divide that into the volume of the members in tension and the volume of the members in compression, which is nothing else as the well-known Maxwell load path theorem. So in the very end, you can decide about what you take from all of these things to do something with that. And then we come to Frei Otto's interpretation of the TRA, applied forces and the distance to the support. Then we can do elephant bending, something like that, multiple bending, structures in compression, structure in tension, and we come finally to graphs like we saw before, if we bring that in together in relation to the peak. And that was very inspiring for me and for us. It's a complete new interpretation of mechanics. Very intuitive and far from hardcore mechanics. Wow, but opens the window to a more entire interpretation of what's going on there. Perhaps you know slides or tables like that. And I don't know when that happened. It was just quite earlier. There just Frei Otto took this TRA as a driving force to come up with all kind of optimal trusses in that case, which all of them are more or less of the family of Mitchell structures. Wow, it's possible. And one of the impacts of today is that we just use that also now in education at TUM, where we have a little tool playing around, being able to measure the overall TRA, the tension potential, the compression potential, that means the respective volumes, or that directly applied to the question about the optimal reinforcement of structures like that, where of course we meet everything what we know from Mitchell, Mersch, Schleich, Frei Otto, the complete Stuttgart school and something like that. And that is now coming back to today and our education in Munich. Now coming back to a quite important point, which I realized is important. I'm now 40 years in optimization, and you learn every day. And the most important problem, if we talk about optimization, is that everybody are looking at your faces. Everybody of you has a different understanding of optimization and of optimality. So it doesn't help if I tell you that it's optimal. You can immediately say it's not optimal, or you have a completely different understanding. And the main difference I have realized between architects and engineering is that what you see here, most of the time, or quite often, let's say, I realized that if architects, they talk of optimizations, they mean to minimize the distance to their vision. So what is that? Remember the presentations of today? We have been talking about visions, observations, visual similarities of structures which we observe in nature and what we build, trees. We built a column. Is that a tree? Well, it might be visually similar, but it's not the same. While on the other side, we say at least, we deal with hard facts, physics. analyzed forces, stresses, displacements, potential energy, and just tried on this basis to formulate an optimal problem like minimizing weight with respect to certain stresses and things like that, which is not the same. Definitely not the same. And then we have heavy fights and also disappointments in particular. It's a typical case that architects say, oh, you are doing calculations for hours and then something drops out which I can't use because it's not what I wanted to. Well, believe me, it's optimal. No. That is really interesting. So, of course, the best was the best of both. And that's how my experience with Otto was his approach. He always tried to bring these two things together. And in particular, his arguments about minimal surfaces is one of these examples. Not only some surface, the minimal surface. And he was insisting of things stuff like that, which also we can realize with the Olympic roof discussions, where he was always insisting on some extra truth beyond that, and we say that then the font is definitely smaller than 10, if you try to bring these things together. And that is really one of the nice things that in the meantime, at least once you had been very successful with the chair, that we just had introduced these ideas in our collaboration with BMW, with the shape module, where they really have understood that also with the vision of a car builder, they also have visions, surprisingly, I don't know, that we can bring it together, the vision of what it should be, together with physical facts, and just by combining that to find a better solution, perhaps better than everything else what we had before. And I would mention Machito Yat, one of the doctoral co-worker of that time, who was implementing that now at BMW. Very interesting biography. His father is professor of architecture at Tehran. He studied mechanical engineering and did his PhD at my chair. So it's everything of everything, let's say. And it's quite often, I can say, things like that are transported through the people and the characters and the personality. And there, Frei Otto is one of our really great predecessors, just following that regard. And who knew about that? That Frei Otto is always trying to bring these together. That was Klaus Linkwitz. You see him here at an excursion of the Olympic Park at the north entrance. We're just pointing at the north entrance, and you know that he was also writing that. And he claimed that to be the masterpiece of Frei Otto, the shape and the structure of the north entrance, which, as Klaus said, was the closest possible distance to a minimal surface. As the experts among you, you know that it's hardly impossible to find the shape of a minimal surface by cable structures, definitely, but that is really very, very close to the ideal case with how many thoughts? What do you think? 0, I guess, bringing together vision and facts. And talking about gravity and the nucleus of gravity, we also know that it does not make sense to bring together several attractors together in a close distance that will always lead to a nuclear fusion, something like that. But we have heard about it, was the case at the Olympic roof and the Planungsgruppe Dach. And now we are ready, Eureka, by understanding what is there, to expand these experiences and this approach, the opposite route, to other problems like what we discussed here. And I would now quickly run through many of the applications and things what we did at our chair, so that you understand how these basic ideas, which I have learned and experienced here at this tent, standing at the position and center of gravity, also in our group and our research. And thanks to all of them who have been collaborating and working over all the years. 2 of them are here, Roland Wichner and Ann-Kathrin Goldbach. I would like to start with a recent result of mine. Personally, we just have been working about the revision of the force density method, being able to show that the force density method is really a consistent part of mechanics. That is not a trick. That is really consistently embedded in continuum mechanics. And what you see here, that's the application to a little experiment again along Stuttgart 21, where we just take here a hexagonal mesh. Really, it's not also to expect it that we get by this as close as possible to the minimal surface as far as it is possible with the approach. And going back to papers by Frei Otto, where it just was discussing the optimal properties of meshes. Then all of us, we know it. The hexagonal mesh, is indeed a very good choice to say like that. Last year in the ISS conference in Zurich, I saw this contribution by Raphael and Sigrid. I just had this pedestrian bridge with a circular basic arch. And when I saw it, what they presented, I immediately saw this hexagonal mesh again, and it was reminding me to this experience here from SFB. And what I want in particular pointing to for the experts among you, look at here the convergence history. It is indeed quadratically convergent. So we have now really reached, I would say, the final stage with all many constraints, controlling the position, controlling lengths, controlling forces in this structure, and quadratic convergence. Message to everybody, to you, you should also look into numerical mathematics to understand what's going on. That is something from 2 years ago, the inverse force density method for generating force diagrams. That's the expansion into membranes to really find minimal surfaces some years ago. That was a little exercise together with Heinz Isler to study something about the Stuttgart 21. It was from 98. I never saw some results out of that. Then we had been members of the campaign to do the evaluation for the umbrellas in Mecca and Medina. So then the inclusion of everything, what I showed you, into cut, simultaneously cut and analysis in all regards. And finally, that's the final stage. Ask Anne-Catherine about that. Complete inclusion of form finding, cutting pattern analysis, and compensation to do all these. It have been applied, among other things, this technique for the Venedig Biennale. That is a cooperation with Geobrook for protective structures to prevent alpine hazards, where you see we have a net, not surprising, where combining that with the interaction of modeling here, Lawine, genau. A complete different story is generating shape. It's like with playing around with spatulas and clay. And the trick is that we have developed a moving spline completely independent of any control polygons. And that made it possible to go into free form shape optimization of all kinds of problems. If you go to the Deutsche Museum, you will see these tensegrity structures with those nodes. We just have applied that for the optimization of that shape. Besides, with the revised force density methods, no problem to go into any kind of tensegrity structures. That's the application to these icons of shell design, here to Rojas shell, and you see what is possible by this application to improve the structure. And we have here how many shape variables, 80,000 or something like that. So the number of shape variables is not the point, completely flexible. That is applied to the Candela shell from Valencia. Hello, Carlos. And surprisingly, it just appears that building here inside a little positive curved surface makes the structure really much, much better. So again, what is optimal, the vision or the fact? And what is optimal? So nobody would accept that as a Candela shell with this, you see it better. But if you look at the distribution of shell stresses and deformation, it's much more homogeneous as the solution by Candela. That's an application for 3D printing and topology optimization of the same approach. That again, a collaboration with BMW for something additive manufactured together with optimal storage. And here we see a little movie where it just comes out of the printer, these pieces, I think they belong to the Rolls-Royce. A little project together with Volkswagen, a pilot project for the shape optimization of the car body of the Polo. That was our largest problem we ever applied, but with 3.5 million shape variables, so it's no limitation. And everything along with basic ideas, which I have learned here. And perhaps you did the game and you're overthinking about what is the thought. We are now really in outer space. We are in a far distance from EL, but the principles still apply. And the last example I would like to, that's that one here, though. That's a real application for the optimal layout of this racing car with respect to minimizing the air resistance, being as fast as possible with the constraint that it should not fly away. And that's the last example I would like to show. I'm really happy with this example. That's by MTU, and they just implemented the technique by themselves. And when we had been talking about it, I was so surprised because they wanted to know from me everything, all stories of Frei Otto and the SFP 230. What is going on there? So they really have read about all the things. They knew about it at least a little bit, and was pretty much interested in these ideas to apply that to a problem like this. What is this? It's a tool pin plate of the air compromising device in the turbine, completely out of scope what we discuss here. But of course, it's an airplane. It should also be light. So that's the outcome at the very end. What we are able, and we are now in orbits far in outer space. But however, in MTU, I was wondering, is it really far away in outer space, or with respect to discussing the opposite route, are we very close? So both is possible at the same time, being far away with respect to applications, but very close to the ideas of the opposite route, thinking about the principles, the natural principles, and applying that to all kinds of different aspects and questions. And of course, finding results which are unexpected, new, and definitely could not be compared to questions which we discuss here in the context of architecture. We are now really very far out in outer space, and let's now go back, just following the gravitational force of the spirit of lightweight construction. It's no surprise where we end up back to Earth, and remembering Frei Otto and his impact to all what we discuss here, and optimization. Thank you.